Hello and welcome to this learning video. Till now we have discussed four different properties of Laplace transform, and here in this we are going to discuss the fifth property of Laplace transform, which is, you can easily see from the result only, that function divided by t. So this is the fifth property, which is division by t property. And this is the fifth one that we are going to take. Okay, so what this property says? This property says if Laplace transform of f of t is f of s, then prove that Laplace transform of f of t by t is this, and hence we have to find out one Laplace transform with the help of this property. Okay, so how we can start with? We can start with the given thing. Proof. So what is it? Laplace transform of, which is given Laplace transform of f of t is equal to f of s. Okay, but what is Laplace transform of f of t by definition? By definition, it is integration 0 to infinity e to the power minus st into f of t dt, which is equal to f of s by definition. Okay, if you want, I can write by definition. Clear? Now if you look at the result, in the right hand side we have integration and the limit are s to infinity, and we have in the right hand side only f of s. So this is helping me out in writing down the next step. So what I will do is, I will integrating with respect to s, integrating with respect to s from limit s to infinity, we get. So what we get already one integration is there, so I will write it as like integration 0 to infinity e to the power minus st f of t dt. This is already we have, and we are integrating from limit s to infinity. ds is equal to integration s to infinity f of s ds. Clear? Now as you can see here, these s infinity, 0 infinity, these all are constant. Okay, and just because these all are constant, either I integrate with respect to t or either I integrate with respect to s, that doesn't affect the value or the solution of this integration. Okay, so we can change the order of integration. So I can write as both the limits in both integration are constant, so by interchanging, by changing the order of integration, by changing the order of integration, by interchanging the limits of integration we get what we get. Now see here, changing the order of integration. So I will take this outside and write integration 0 to infinity. Taking this as integration s to infinity e to the power minus st into f of t ds dt is equal to integration s to infinity f of s ds. Okay. Now continuing here, this thing. So this is integration 0 to infinity. Now this is integration with respect to s. Integration with respect to s. So you can take the function of t outside. So you can write like this also, ds into f of t. Okay. So what is integration of e to the power minus st with respect to s is e to the power minus st divided by the coefficient of s is minus t, limit s to infinity. Okay. Into f of t dt is equal to integration s to infinity f of s ds. Okay. Now this applying the integration, upper limit minus the lower limit. So this is integration 0 to infinity, then applying upper limit minus lower limit. So this will be e to the power minus infinity by minus t minus minus plus e to the power minus st by t. Okay. Into f of t dt integration s to infinity f of s ds. Clear? Now e to the power minus infinity is 0. So this first term is 0. So we remain with the second term. So this is integration 0 to infinity e to the power minus st into f of t by t dt is equal to integration s to infinity f of s ds. Clear? Now what is this? This is nothing but the definition of Laplace transform. That is Laplace transform of f of t upon t is equal to integration s to infinity f of s ds. And this completes the proof of this property. Okay. Now as you can see, there is one result that we have to find out with the help of this property. So let us find out that result first. I am rubbing this now. Second part. Okay. We have to find out Laplace transform of sin t upon t. The result says Laplace transform of f of t by t is this. So what is f of t? By comparing this and this, f of t is sin t. So you can write, let f of t is equal to sin t. This implies f of s is equal to Laplace transform of sin t is 1 upon a square plus 1. Okay. Now making use of the property. By the property we have, what we have by the property, Laplace transform of f of t upon t is equal to, what is it? Integration s to infinity f of s ds. So put f of t is equal to sin t. We get Laplace transform of sin t upon t is equal to, so what is Laplace transform of sin t upon t? integration s to infinity f of s. What is f of s? I have already found out. 1 upon s square plus 1 ds. Now you should be smart enough to write down the integration of this. This is what? This is 1 by 1 into 1 upon s square plus 1. So this is integration of tan inverse of s. So this is tan inverse of s from limit s to infinity. Okay. Now applying upper limit minus lower limits, will be getting tan inverse infinity minus tan inverse of s. So this is tan inverse infinity pi by 2 minus tan inverse of s, which is equal to cot inverse of s. Pi by 2 minus cos theta, tan inverse theta is cot inverse theta, and this is Laplace transform of sin t upon t. So this is the result. Okay. So are you getting it? Yes. Now one extension to this theorem. As you can see, this is Laplace transform of f of t upon t. How many integration? 1. If t to the power 1, 1 integration. If Laplace transform of f of t by t square, then you have s to infinity f of s ds square, right? Likewise, in general form, if you want, what would be the Laplace transform of f of t? The general form of this is Laplace transform f of t by t to the power n is s to infinity, limit s to infinity, and so on, and the integration of f of s dsn. Okay, so these are the extra knowledge. Okay, you must remember, because such things sometimes asked in the competitive examinations like GATE or NDA or CDS. Okay, so I hope this is making sense. So thank you for watching this learning video, and happy learning. Thank you.